Hey everyone, welcome to this new series of machine learning ML. So, when you hear this name ML, so you might think of, a complex system having some robotic structure and which is used to do some complex things. So, usually you think of this thing. But here, I want to clear the air right now. ML is not at all a new application. Okay, it has already been there for decades. Okay, mainly when you look at this particular field, that is this particular technology, that is OCR, is nothing but optical character recognition. So what is meant by this OCR? So this OCR nothing but, for example, I have an image. Okay, let's consider I have an image, maybe a Python cheat sheet. Okay, this is my Python cheat sheet. Okay, so now you already know this. Whenever I say cheat sheet, it usually includes all the texts. Okay, all the coding things and related to Python that usually present in a textual format. Okay, so it is a kind of an image, it's a kind of image in which some textual data might present. Okay. And you want to convert this textual data from image format to a readable machine interpretable textual format. Okay. For example, machine readable textual format. You want to convert this. Okay. From image to this thing. You want to convert this thing textual. Then how to do that? Using OCR technology, that is optical character recognition, you can easily convert an image which is having some textual data to a pure text thing. After you convert this image to a textual kind of thing, then what happens is, for example, here if you take any image, if you just try to select the textual data in this image, you can't even select. Why? Because it is in image format. But here, after converting it into a textual, proper textual format, then here you can easily copy that, you can paste wherever you want. So this is the use case of this OCR. But why I'm actually saying about this OCR is, I'm saying ML is not at all a new technology. Okay, it has already been there since decades, especially in this OCR kind of technology, that is optical character recognition. So that's why, that is the reason I have told you about this OCR. Okay, but now I'll give you a example. This time, it would be a very close example to your life. For example, everybody use this application, that is Gmail. Okay, whenever you go to Gmail, we have so many columns under our menu. For example, we have inbox. After that, we have maybe social, in the sense this section is for YouTube, Twitter, and all the other social media accounts which has been registered through your Gmail account. Okay, and this is for maybe send items, and after that you also have some kind of section called spam. So this is your spam here. So what is this section called spam here? Whenever, for example, if this is your email, if this is your Gmail interface, okay, here you will be having all the emails likewise in this particular format, okay. And if any new mail comes, okay, if any new mail comes, our Gmail system or the algorithm which is actually deployed in this Gmail application, it usually detects, or it usually classifies this new mail, whether it is a spam, whether it is a spam or it is a ham. What is meant by spam and a ham? Spam is nothing but, for example, you will get emails repeatedly, which is containing, for example, mm, maybe some kind of spam words, for example, loan offer, with the keywords loan offer and 60% discount. So these are all the spam emails which we really don't want to, consider here. Okay. Why? Because every time you'll get some dozens and dozens of emails with these particular keywords, that is loan, offer, and discount. So likewise, so you'll get irritated by seeing all the unwanted emails. So for that purpose, Gmail has provided an option called spam. In under the spam folder, what happens is here, whenever a new mail comes, our algorithm, that is the machine learning algorithm that is running at the back end of this Gmail application, it usually classifies whether this particular email is belong to a spam category, in the sense, if the content, or if the subject, or if the description of the email uh, contains any keywords which are actually spam. If it contains any spam keywords, then automatically it classifies under spam category. And what is meant by ham? Ham in the sense, it is normal, in the sense it doesn't have any keywords which are related to spam. Okay, it's a pure mail. It's a normal mail. If it is a spam, automatically our machine learning algorithm, it classifies, or pushes the it pushes that new mail under this spam folder. If it is not having any keywords which are related to spam, then automatically this new mail would come under your inbox category here. Okay. So this is the scenario where we call this algorithm as spam filter. Okay. Here, the name of the machine learning algorithm which does this job is spam filter. Why I'm actually saying this is, I want to give you an example related to ML. So this is the ML application. So spam filter is nothing but an example of machine learning algorithm which does our job, which usually classifies any new mail whether it belongs to a spam category or a ham category. Ham is a normal one. Ham is a normal true one, true mail. But this is not a normal one. This contains few spam words. So maybe I mean spam keywords. I see. So that's the thing. And also after this, the machine learning field has already been developed from this spam filter too. Earlier it was only presented in this spam filter. Nowadays we are looking it everywhere, in the sense maybe recommendations. Whenever you go to Amazon or any Flipkart or any other e-commerce application, you'll be getting some kind of recommendations, like people are usually buying this particular product. For example, if you buy any laptop, okay, then they'll say people are actually preferring this laptop along with this Logitech mechanical keyboard. Okay, so you'll get an recommendation like this. Then what do you think usually? Okay, you have bought a laptop. Then obviously you can't even type every time on this keyboard that has been provided with the laptop, right? Why? Because it's a sensitive, so you can't. I mean, you can't really type some hard kind of typing on this thing. So you need a external keyboard. So obviously you might think this would be a better suggestion or better recommendation. So you definitely think about buying this thing. Okay. So this is nothing but a recommendation. So ML has been developed from spam filter to recommendation systems to nowadays also we have AI assistants, or in the sense maybe your Google Assistant, that is voice search. For example, if you just talk about, I mean, if you just ask for okay Google, then automatically your Google will respond to your voice. In the sense, depending upon your voice, the ML algorithm is actually getting responded, and it is actually doing the job that you may ask through your voice. So from spam filter to till here, recommendation system and voice search, ML has been developed a lot since it is first introduced. Okay. Now, what I'm saying is, I'm gonna tell you now in this particular series that I have started right now, I'm gonna explain. First of all, I'm gonna tell you supervised learning versus unsupervised learning. So I want to tell you, I want to explain this particular supervised and unsupervised in a greater detail so that you will understand better. And I also want to tell online, what is the difference between the online and batch learning. Also, I want you to focus on this instance versus model based learning. And also, I want to explain how it will be the workflow of any ML project, complete project, workflow of an end-to-end ML project with hands-on. I'm gonna tell you. Okay. And after that, we also have this is very much important. Why? Because most people usually think whenever we are learning something, maybe these topics, supervised, unsupervised, online, batch, instance, model based. So people may usually think they have mastered everything. No, even after they implementing everything through code, they won't master everything. Why? Because uh, learning is not only enough. We also need to know what are the limitations and what are the difficulties that we face while deploying any machine learning model, or while running any machine learning model. If you want to get better accuracies, or if you want to get better results, so what do you need to do and how to overcome these challenges? I'm going to tell you. So challenges and how to face them, how to face the challenges in ML, and also how to evaluate them, how to evaluate a model, and also I'm going to tell you hyperparameter tuning. Whenever uh, whenever I say hyperparameter tuning, this is nothing but you have a model. Okay, this is your model, and you have got some accuracy, maybe 7.5, or in the sense maybe 75%. Let's imagine you have got an accuracy of model accuracy of 75% for your model. Maybe you're running some, maybe uh, just imagine maybe you random forest or something. Okay, you have got some 75% accuracy. But what happens is here, after that, and this 75% won't be sufficient for you to take a decision upon your situation. Why? Because this 75% won't be enough. We at least need some 90 to 95%. Okay, or at least 85 would be maybe safest percentage. But this 75 percentage won't at all sufficient. So for that reason, you want to improve your model. In the sense, you want to make your model better than the previous one. So here the accuracy was 75%. Now this time you want to make it to maybe 80 to 90%. If it approaches this 90%, then we can easily see some drastic improvement in terms of accuracy. So here the process of improving in terms of accuracy, or the process of making it better, is nothing but hyperparameter tuning. Here we'll be having few kinds of parameters. For example, maybe your maybe lambda, or maybe C or something. So it has a particular threshold, maybe 0.5, or maybe something. Just imagine, I'm just giving it as an example, maybe 1 or something. So using these parameters, you would make a trial and error. So if your model is reaching to this 90% accuracy, then you would stop at this particular threshold. So those thresholds or those parameters are the ideal parameters which have helped your model to achieve this 90% accuracy. So this is nothing but, this comes under hyperparameter tuning. Yeah. And also I'm going to explain uh related to how to tell stories related to your data. See here, knowing is not only enough. After knowing, you need to implement it in terms of projects. And after implementing it, you also need to know what are the drawbacks that we have faced in this, while implementing this project. You need to understand the drawbacks as well, because then only you will get improved uh, by your next project. And also you need to interpret as well. Now what happens is, you have got the understanding, and you have implemented some project here. You have implemented some project, and you have got some results here. You have got some results. After getting results, now what is the purpose? Now, what is the way forward here? After getting results, you need to understand them better, and you need to interpret them. So what is the meaning of this particular value, and with this value, what we can do? You need to think in this perspective. Is nothing but, it comes under interpretation. So you need to interpret it well, and uh, you need to tell the stories. Why? Because your client won't understand all these jargons, technical jargons. They won't understand. Why? Because they won't understand what is meant by lambda, or what is meant by accuracy, true positives, true negatives, confusion matrix. They won't understand at all. They only need whether we can implement this decision or not. So you need to do that. You need to convey, or you need to convey the information that you have got in terms of client perspective. Okay. So I'm gonna tell you how to do this thing. Okay. So that's all for this video. I hope you like the content. If you like it, just share it with your friends. And in the coming video, I'm gonna talk about what is ML, and I'm gonna give you a few examples of it. And also I'm going to tell you about the use case of ML. So this time I have just explained some of the use cases, like recommendation systems and voice search and a spam filter, uh, just in brief. But this time I'm gonna go a little deeper into this, related to the algorithm that is actually working behind that model. So I'm gonna tell you everything, how an algorithm works at the back end. Okay. I'll see you in the next video. Thanks for watching. Take care.